Hello, I decided to do my presentation on the speed of light and how we decided what the speed of light was, how we as a society, through different people, have come to discover what the speed of light is. Because light in itself does have a speed. If you look at this dying flashlight on the wall, what you see is actually particles coming right from my flashlight into the wall. It's an energy system that actually has a velocity, and it can be measured, and it has been, and that's what I wanted to explain. Okay, so the first person to decide that, or to actually theorize that light, instead of being instantaneous, was, or had velocity and actually moved through our space, was Galileo. Before Galileo in 1675, they thought that light was a very instantaneous effect, and Galileo was the first one who actually performed an experiment to try to decide the speed of light. And what he did was he had a lantern, and he had another guy about 5 miles away with a lantern, and they'd flash their lights at each other whenever they saw the other light. And there was a very small delay, but because light moves very fast, he couldn't decide the speed of light that way. So all he decided was that the speed of light is more than 10 times the speed of sound. The next person to actually look at the speed of light was the astronomer Romer Ole. And what he did was he looked at the moons of Jupiter, or a moon of Jupiter. I think it was Io was the moon of Jupiter. And you have over here, you have the Earth. And he was looking at Jupiter, and the moon of Jupiter goes around and it orbits Jupiter. And from the Earth gets closer. He triangulated the position, and therefore he discovered that he theorized that the speed of light is 200,000 kilometers per second square, or kilometers per second was the velocity of light. He was a bit off, but he was the closest of his time, which was actually quite interesting the way he did that. The next person who came along in, let's see, 1728, almost 100 years later, or rather 50 years later. But he came along, he looked at the aberration of the solar system. The stars in our galaxy, in our night sky, are actually hitting our eye at an angle based off of the speed of light. It's the same way as if you're standing and rain is falling on you, whereas if you're running, rain is falling on you this way. That's what aberration means. And he looked at the light of the stars, and he could triangulate a position that way, and he came up with a model for the speed of light being 301,000 kilometers per second, which was quite a bit closer, actually. The next person to come along to discover, or to look at what the speed of light might be, didn't look to the stars, they looked here on Earth. What he did, his name was, let's see, Fizeau. He was a Frenchman. He took a candle and he took a cogged wheel here. He set the cogged wheel up, he shot light through the cogged wheel while it was spinning, and he shot it to a mirror, and it went here, it came back. What he was doing was he was looking for the speed of which to spin this wheel, where the speed of light, it would come here and come back through the same cogged position. He knew this distance, and he knew the speed and the distance of this cog, so he could discover the speed of light that way. And what it was the speed of light so big that he had to spin this 100 times per second. He had to have 100 cogs on this wheel, and he set this up about 10 miles apart, and what he did was he focused the light with lenses, because this was back in 1849. All they had were candles and lanterns. They didn't have flashlights, they didn't have lasers or anything to focus the light. He had to use lenses, quite like with telescopes we do now. About, let's see, 10 years later, another Frenchman, they actually were colleagues is Foucault, and he came along and he used the same exact experiment, but what he did was he used a multifaceted mirror and he spun it along an axis. And what it did was when the light came back, it came back at an angle. He discovered this angle here, and by the small angle, he could discover the speed of light. He triangulated it that way, which was even more of a breakthrough than the actual land-based experiment by Fizeau. What he did was he came up with a more modern number of 298 kilometers per second. That's about as close to the speed of light as anyone's gotten in old times. About 50 years later, somebody came along and reproduced his experiment. It was Michelson. He came along, he put a lot more money into it, he built bigger mechanisms, he got the best quality lenses of his time to refract the light better than the capabilities of Foucault, but he still only perfected the actual number down to, I think he took this and he made it, let's see my notes here, a 9 and 796. So he didn't actually make this more precise of a number by that much compared to the actual speed of light that we've now discovered from laser technology and going to the moon and being able to go to space. What the real accepted general principle that light is 299,792.458 kilometers per second. And that, my friends, is the speed of light and how we have gotten there.